In this video, we're going to use the given triangle, the given right triangle, to find the tangent of theta. So you can see the right triangle on the left-hand side of your screen, and we have two different sides that are listed. We have 4, which is the hypotenuse, and we have 3, which would be the adjacent side of our theta. Notice that I have theta marked in red, and you may want to do that just so that you're always sure to take the opposite hypotenuse or adjacent from the perspective of the angle that you're interested in. So on the right-hand side of your screen, you see the definition for sine, cosine, and tangent. So for this problem specifically, we're interested in tangent theta. And tangent theta is equal to the ratio of the opposite over the adjacent. So if we go and start working through this problem, and we say tangent theta, and then we go through the problem like we've done before, and we say, okay, we need the opposite side of theta. Well, when we go to circle our answer, there's nothing there. We don't know what the opposite side is. And so we have to go into a problem within a problem and figure out what that side is. But the good thing is this is, of course, a right triangle, because otherwise we wouldn't be talking about sine, cosine, and tangent. And so what we can take advantage of is the Pythagorean theorem. A squared plus b squared is equal to c squared. And so right here, we're just going to call this side x because we don't know what it is. And so we want to look at the two legs of the right triangle. That would be 3 and 4. So we're going to say 3 squared. That's kind of like the a squared, plus x squared, that's kind of like the b squared, is equal to the hypotenuse squared. And the hypotenuse, or the side opposite of the right angle, is 4. So equal to 4 squared. And now we're just going to solve this for x. So 3 squared, of course, is going to give us 9, plus x squared is equal to 4 squared gives us 16. We're going to subtract 9 from both sides. We get x squared is equal to 7. And when we take the square root of both sides, we get x is equal to plus or minus the square root of 7. Now, of course, we're talking about the length of something, like a real-life object, a triangle, the length. So we're definitely going to discard the negative version because we don't have a length of negative square root of 7. And so x is going to be equal to the square root of 7. And so now we have a value for the opposite side of theta. So now we can go through the process like we normally would and say that tangent of theta is equal to the opposite, the side opposite of theta. So we now know that is the square root of 7 divided by the adjacent side, which we already knew was 3. And so there's nothing we can really do to simplify here. So tangent theta is going to be equal to the square root of 7 over 3. So you always want to keep in mind we're dealing with right triangles and problems like this. So if you're ever missing a side and you have the other two sides defined given numbers, you can always just plug it into the Pythagorean theorem and solve for the missing side like that, and then go through everything.